Welcome to our detailed tutorial on decision trees for regression. In today's video, we will explore what decision trees are, how they work for regression tasks, and implement a decision tree regressor in Java step by step. Before diving into the code, let's first understand the concept of decision trees and how they are utilized for regression tasks. Decision trees are a type of supervised learning model that split the dataset into subsets based on certain conditions. For regression tasks, the leaf nodes of the tree represent continuous values rather than classes. The key idea behind regression trees is to minimize the variance of the responses within each of the generated subsets. The decision tree uses measures like mean squared error to decide where to split the data. In regression trees, each internal node represents a feature or attribute. Each branch represents a decision rule, and each leaf node represents an outcome, a continuous value. Let's start by setting up our Java environment. We will use the popular Weka library for machine learning tasks. First, make sure you have JDK installed and properly set up. Next, we need to download the Weka library. You can download it from the Weka website or include it as a Maven dependency. Now we will create a Java project. Open your favorite IDE and create a new Java project. Let's call it Decision Tree Regression. In our project, we will create a main class called Decision Tree Example. Create a new Java class in your project. We are going to use the famous Boston housing dataset to illustrate our decision tree regression implementation. You can download the dataset as a CSV file from various sources online. For our program, we will load this dataset into Weka's data structure. Ensure you replace the path / Boston_housing.csv with your actual file path. When we run this code, it will load the dataset and set the class index for regression. Next, we will build the decision tree model. We'll create an instance of the Weka.classifiers.trees decision stump to train our model on the dataset. We used REP tree, which is a decision tree implementation that provides regression capabilities in Weka. Now we can evaluate our model on some test data. To evaluate our model, we can use cross-validation, which helps us assess how our model performs on unseen data. Weka has built-in functions for this. The cross-validate model method performs a 10-fold cross-validation. It divides the dataset into 10 parts, trains the model on 9 parts, and tests on the last part repeatedly. This gives a good estimate of the model's performance. Once we have the evaluation metrics printed, we can delve deeper into specific metrics by inspecting the eval object. Weka provides a variety of metrics such as mean absolute error, root mean squared error, and more. Now that we know how to train and evaluate a decision tree for regression, let's visualize the tree to better understand how it makes decisions. This will print out a textual representation of the tree structure. Each node indicates the decision-making process, helping us understand how input features lead to a final predicted value. But what if we want to serialize our model for future use? Weka provides functionalities to save and load models easily. This code snippet will save our trained model into a file named decision_model. You can later load this model for making predictions without retraining. Now that we have our model saved, let's see how to make new predictions using it. For that, we need to create an instance of the new data. Make sure to replace the ellipsis with actual feature values corresponding to the attributes of the dataset. This will classify the new instance and predict the outcome. As we wrap up, let's summarize what we've learned today. We discussed the fundamentals of decision trees, how they operate for regression, and implemented our model in Java using the Weka library. We explored dataset loading, model training, evaluation through cross-validation, model serialization, and making predictions. You now have a solid foundation in implementing decision trees for regression in Java. Please make sure to like this video and subscribe to our channel for more detailed tutorials on Java and machine learning concepts. Thank you for watching and happy coding.